we'll compute the determinant of this 4 by 4 matrix. It's worth looking at it and seeing if there's a row or a column that has a lot of zeros. Looking at this one, you see the second row has 3 zeros, so let's choose to expand the determinant along that row. What we need to pay attention to is the sign of the coefficients, and so I will write down the checkerboard matrix of pluses and minuses that will help us determine. So we see that if we're going to move along the second row, we have plus minus, or sorry, minus plus minus plus. So what's the sign of the coefficient 2? Looking here, it's a, it's a plus. And we will multiply this by the determinant of the 3 by 3 matrix that consists of those entries. So now I'll write them down. 5, 2, 3, minus 4, 1, 1, 7, 2, 0. And that's the only 3 by 3 determinant we'll need to compute because the other entries of the second row are 0. And again, to compute the determinant of this 3 by 3 matrix, it's worth examining the rows and columns and seeing if there's one that has some zeros in it. So we see we could go along the third row or the third column, and we'll save ourselves a little bit of work. Let's move along the third row. So remember to include our factor of 2 that will multiply the entire determinant of this 3 by 3 matrix. Moving along the third row now, we'll start with the 7. Ask yourself, what is that a plus 7 or a minus 7? Again, you want to think of the checkerboard matrix. Now we already have it written here for a 4 by 4, and so you can look at it for the 3 by 3 case as well. Plus, minus, plus, that 7 will indeed have a plus. And it will get multiplied by a 2 by 2 determinant with the entries 2, 3, 1, 1. I'll circle them in red. Okay. Then, moving along that third row, the next coefficient will have a minus sign. It is 2. And that will get multiplied by a 2 by 2 determinant with entries 5, 3, minus 4, 1. And then the last coefficient is 0, and so we really don't care about that determinant. We don't need to compute it. So now we compute these 2 by 2 determinants. 7 times 2 minus 3 will give minus 1. Minus 2 times, 5 times 1, minus 3 times minus 4. It's easy to make little mistakes, so we'll be careful if there's a negative sign. 5 minus 12 will give 17. Okay, you work this out, and this will give minus 82. Now, just for fun, I'm going to compute that same determinant along a different row or column. Let me choose the fourth column. It still has 2 zeros in it, not 3 zeros like the second row, but it will still be efficient. So moving down that fourth column, we have a coefficient of 3. It is going to be a minus 3, and that is going to get multiplied by the determinant of this 3 by 3 matrix, 0, 2, 0, minus 4, minus 3, 1, 7, 1, 2, found as follows. There's the 3, and there's the 3 by 3 submatrix. And then, again, moving down that third column, the next coefficient would be plus 0. That will give 0, so let's skip that entirely. The next non-zero coefficient will be 1. Again, it will have a minus sign associated with it, and it will get multiplied by a 3 by 3 determinant with 5 minus 1, 2, 0, 2, 0, 7, 1, 2. Let me circle it in green. Those entries there. And now we have to compute these two 3x3 determinants, which seems like a lot of work, except each of them are not too bad. Look at this 3x3 determinant here. Notice that the first row of this 3x3 submatrix has 2 zeros in it, so we'll compute along that row. So we'll have a coefficient of 2, which has a minus sign associated with it, and then the following 2x2 determinant, minus 4, 1, 7, 2. There, I've circled it in orange. And now for the second 3x3 determinant, we see the second row here has 2 zeros, so we'll have a factor of 2, but now be careful, this 2 will have a plus sign associated with it, and it will get multiplied by the 2x2 determinant 5, 2, 7, 2. So here we'll have minus 3 times minus 2 will give 6, minus 4 times 2 is minus 8, minus 1 times 7 is minus 7, and then minus 1 times 2 is 2, and then 5 times 2 is 10, minus 7 times 2 is 14, and this will simplify to give minus 90 plus 8 is minus 82 as